want you to confirm if you are seeing what I'm, showing, projecting right now. Can you guys confirm what I'm projecting right now?
Yes.
Okay, thanks for that. Like I said, today we are starting a new topic. I told you before, statistics is more or less like a story, okay? A story that doesn't end. The problem in the world, okay, most of the topics that you have in statistics, okay, actually address problems in the world, okay? And it now depends, the kind of statistical method that you actually want to use depends on the goal, depend on the problem that you actually want to solve. This is actually going to be taken from chapter 10 of the textbook. And I also want to tell you there are other supplementary materials. Give me 1 second. I'm actually going to share. I'm going to go into the dashboard for you to be able to see the relevant material that we're actually going to use uh, today. Okay. Uh, and the R's, code, the worksheet are also already uploaded. Okay. And I'm actually going to, share that with you right now. Uh, can you guys see my wipe? I mean, can you see the dashboard right now? Week 7.
Yes.
Okay, so today is 21. Okay, this is a lecture material, the lecture note on canonical correlation. And you know what? There's a worksheet. Okay, if you really want to know how to do that manually and using the R, the combination of the manual and the R software. And here I put how you can do that in R. Okay, you can actually follow the code that was done. Then I put the how code. Okay, all these are connected with what I want to teach today. Okay, so so that is today, July 21. Okay, in addition to the lecture material, you're actually going to have 3 supplementary materials. Okay, now going back to the lectures of the day, and I'm officially welcoming you to the lecture for the day that we call canonical correlation analysis. And let me tell you this: why canonical correlation? Some of you have heard about correlation before, okay? In statistics, if I'm looking at the relationship between two variables, okay? If I want to know the direction of the relationship, if I want to know the strengths of the relationship, what I'm actually going to do is to compute correlation. But let me tell you this: statistician, the data scientists, you know, um, the machine learning expert, the researchers, and so on like that, what they have done, what they normally you want to do, is majority of them actually have been studying the correlation between two variables at a time. Okay, they are focusing on just two variables at a time. But what is the meaning of canonical correlation, and why does it, is there difference between the canonical correlation and the correlation that you guys have heard about? The answer is there is no difference between that, but only that instead of us to focus on, you know, just two variables, we are actually going to be focusing on these two set of multivariate variables. Variables, okay? Multivariable. I'm going to tell you right now. I'm going to give you an example of that. You know, the correlation that you guys have been doing before, of course, you can look at the correlation between height and weight, okay? But what if in a situation whereby I got some set of variables, okay, here in this group, I also guess another set of variables in the another group. And you know what? And I actually want to figure out the correlation between the linear combination of these two sets of variables. I'm going to say that again. We are seeking to get the correlation. There's going to be pairs of correlations in an attempt to study linear relationship between the two sets of variables. And you know what? The two sets of variables are actually measured on the same individual. I'm going to give you an example right now. The first example I'm actually going to cite will be an example that comes from, maybe I want to talk about X, an exercise. I'm going to say that again. I'm going to have a new share right now. I'm going to share my whiteboard. Uh, for those who may not be hearing me clearly, okay. But I need to confirm right now. You guys see my whiteboard?
Yes.
Okay. So thank you for that. Oh, so if I'm looking at X and exercise, okay. I'm looking at X and exercise, okay. And you know what? Under the X, there are a lot of variables, okay. Maybe I want to look at a cholesterol level, the blood pressure, the glucose level, and so on like that. We got some variables under the X. And under exercise, we also get some variables, okay. Maybe variables like push up, okay. When you are doing, I think, can you guys see me right now? Can you see me?
Yes.
Hey, so the kind of push-up that you guys that used to do, like when you want to do exercise, that you're just going to do your push-up like that, okay? So that is a push-up I'm talking about, okay? And maybe you try to look at the uh, the number of minutes that is going to take you to run a certain distance, okay? You do different kind of exercise, okay? And those exercise, we have kind of measurement on that, okay? And it's the same individual. Now, it means that we get two sets of multivariate. We get two sets of of variables, two sets of multivariate variables, okay? Under the X, we get a lot of variables. Under the SXI, we got a lot of variables. And what we are trying to do in canonical correlation is just to be able to look for a way to maximize relationship between the linear combination of these sets of variables in the two groups. That's exactly what we're trying to do in canonical correlation. And we actually want to use the idea of mathematics, okay? We want to use the idea of statistical theory that we've done before to be able to actualize our dream, the goal. Another example that I'm actually going to give you right now. Can we actually study relationship between school environment and student performance? School environment. That's going to be another example, okay? I'm taking this as number one, and I'm going to take number two as, school environment. Okay? School environment, and student performance. Okay? And student performance. Okay? We can actually, under the school environment, we're going to have some set of variables. Okay? And the student performance, we're also going to have some set of variables, okay? And what are we trying to do? We're trying to look for, the correlation between the linear combination of these two sets of variables with an attempt to be able to figure out, the pair of this linear combination that we have the maximum correlation. That's what we're looking for. And those ones that have the maximum correlation, of course, that is going to be of interest in canonical correlation. Okay. Now, there's a lot of examples that we can actually talk about. I could remember, well, when I was looking for location, when I was looking for a place to stay in the state of Minnesota, because I got children, then I'm actually looking for a very good school district, okay, where I believe my children will actually will be able to gain, okay, the Lord, because the school environment could have effects on student performance, because the school district and are not ranked equally, okay, and that was the reason why some parents may have certain school district in mind, okay, the environment, the school environment may have relationship with student performance. But here, under the school environment, we got some set of variables that are measured, okay, and the performance. And for your information, the two set of variables, the two set of multivariate variables are actually measured on the same individual. Can you guys hear me clearly?
Yes.
Thank you for that. Thank you for confirming that. Now, our intention, what we want to figure out, right? The next thing that I want to walk you through now is to walk you through the mathematical way, because if we really want to achieve something like that, we actually need to go mathematical and we need to go statistical, okay? And that's exactly what I want to walk you through now. Now you know our motive, you know what we want to achieve, you know the goal. But the next thing now is to go into mathematical or statistical architecture of how to be able to figure that out, okay? And that is what I'm going to walk you through right now. So all what I'm going to be discussing now is actually going to be mathematical, okay? At the same time, statistical, okay? But you know our intention. Now, okay, so I'm going to walk you through the description right now. Now, looking at the description, like I said, we're going to have two sets of variables, okay? Observe on unit. And we're going to have set 1 will contain some p variables, and set 2 will contain some q variables. But we do it in a way that, the number of variables in set 1 must be less or equal to the number of variables in set 2. Okay, we did this for convenience. It's just for convenience. Okay, you got to make sure that what you're going to put in set 1, the number of variables in set 1 must be less or equal to the number of variables in set 2. That's exactly what we're talking about. I talk about school environment and student performance. It means if I put a school environment in set 1, the number of variables that I'm actually going to consider in the school environment must be less or equal to the number of variables that I'm actually going to, consider in student performance. And I told you that the goal is to measure the association between the two sets of variables, okay? That is our goal. And you know what? We actually going to make use of the idea of principal component analysis. You remember in principal component analysis, after you have constructed the principal component analysis, the first principal component analysis will contain the combination of the independent variables, the input variables. Also in canonical correlation, we're actually going to have a linear combination like that, because we are not just seeking, the correlation between the pair of variable alone, but what we're seeking the correlation between the linear combination of the variables. Linear combination. I'm going to say that again. Linear combination of the variable. You remember when we started this course, I was walking you through linear combination. Now we now want to apply that, okay? How can we say correlation between linear combination? We're not talking about correlation between x1 and x2, but we're talking about the correlation between the linear combination of x1 and the linear combination of x2. That's what we're trying to talk about, okay? And that's exactly what I'm talking about right here. And you know what? The linear combination will be uncorrelated with the previous ones. You know, in the principal component analysis, you know, it is done, it is constructed in a way that the first principal component analysis, the first principal component is not going to be correlated with the second principal component. We're also going to have the same, you know, situation right here where the linear combinations of the two set of variables have to be uncorrelated, okay? That's exactly what we're talking about. And you know what? The pairs of the linear combination will actually be is going to be much more canonical variables. The pair of the linear combination will be called canonical variables. And the relationship between the canonical variables and the canonical correlation. I'm going to say that again. If I want to investigate canonical correlation, then I need to first set up canonical variables. And what are the canonical variables? The canonical variables, is just basically the pairs of linear combination. Therefore, when I'm seeking relationship, when I'm seeking correlation between the linear combination of variables, then I'm looking for canonical correlation. And that is the difference between the canonical correlation and just ordinary correlation that you guys have heard about. Okay, and that's exactly what we're going to be doing, okay? So which means we are seeking correlation among pairs, okay, of this linear combination. There's going to be a lot of linear combinations. So we're seeking for that, then we're dealing with canonical correlation. Now, if you can you guys see what I'm projecting right now? Can you guys see this column vector?
Yes.
Thank you so much. Thank you for confirming that, okay? Now, I told you what I have right here is a set of variables is the first set of variable, and this is the second set of variables. I talk about school environment. Maybe this is for school environment, and some variables measured, the variables that made up a school environment, okay? And maybe this guy here at the school, at the student performances, okay? Maybe performances in different subjects, okay? That's exactly what we're trying to talk about here, okay? And if you take a look at it, the number of variables here is P, okay? And the number of variables here is Q, okay? And when you are constructing canonical correlation, your data setup, you got to do it in a way that, okay, the number of variables right here is going to be equal to the number of variables right here, or it is less than the number of variables right here. That is exactly what I'm trying to talk about. Okay. Now, of course, you actually need to find the average, okay? This is going to be like the average of the first set of variable, okay? And this is going to be the average of the second set of variable, okay? And when you have, this set of variables, you can talk about the variance covariance matrix based on that. And I'm actually going to call that sigma 1, 1. It means I'm talking about the variance covariance for the, for the set of variables, that I have, the variable that I have is set 1. And I'm also going to have the variance covariance for the variables that I have in set 2. This is the variance covariance for that. And I'm going to call that, sigma 2 2. And of course, right here, this is the general covariance, across. You are going across. You are actually going from set 1 to set 2. And that is why you can say this is like a general variance covariance. Okay. And you know what? I can actually put the two of them as a one vector. Look at that. That's what I'm trying to put right here. That, okay, this guy here is actually talking about the whole of that. And this guy here is actually talking about the whole of this. Okay. And you know what? I can talk about the mean of each of that. I can combine the mean of each of that. And you know what? I can actually set up, the general variance covariance structure is actually going to look like this, okay? And you know what? This guy here, if you take a look at this guy here, is actually talking about this guy here, okay? And if you take a look at this guy here, it's actually talking about this guy. And if you take a look at this guy here, automatically talking about that guy. Before I move to the next slide, is there anyone who have a trouble time understanding the mathematical architecture of the way the data set, okay, in canonical correlation should be? Is there anyone who need clarification on what I've just explained right now? Is there anyone?
Can I have a question?
Yeah, go ahead.
So will the sigma 1, 2 be given in this case?
Will sigma want to be given? Is that what you said?
Yes.
Yeah, let me tell you this. Maybe for the purpose of the exam, but if the way I'm teaching you right now is just for you, like if you want to do a research, maybe you graduate or you want to do a personal research, of course, you're actually going to start with a set of data like this, okay? When you start with a set of data like this, you are going to be the one that will figure out all this, okay? But you know what? We got a software. We can use software to be able to figure out the whole of what I have here. But the fact remains that if you have this set of variables, okay, you will be the one that will work, that will be able to get everything here. Does that make sense to you now?
Yeah.
But I'm actually going to walk you through how you can do that, because the way I'm doing it right now is just that, okay, if you want to carry out if you're looking for canonical correlation, okay, you actually go to, this is like walking you through a model description, from your data setup to analysis and so on like that, okay? But what I'm trying to show you right now is just, okay, your model description, okay? Now, still on the model description, you've been able to obtain other one. Now, the next thing that we want to do, our goal in canonical correlation is to be able to summarize the structure of this. What do I mean by this? Okay, if you go back, that is what you just talked about. You're talking about the covariance structure, okay, between the two set of variables, okay, between the two set of variables. Don't forget, right here you got a multivariate set of variables, and right here you get a multivariate set of variables, okay? And this guy here is talking about the variance covariance in the two set of variables, okay? That's exactly what we're talking about. And you know what? The goal is to summarize the structure of that through a few linear combination of x1 of this and this, okay? Now take a look at this. This, guys, is just the set of variables in set 1. And this is set of variables in set 2. We don't want to make use of all the linear combinations. We are actually looking for few, just like what we did in principal component analysis and in factor analysis. We always focusing on reducing the dimension, okay? We don't want to, though we're looking at the relationship, okay, among the set of, variables that are linear combination, okay? But you know what? We are not going to make use of all the linear combination, because the goal is just to, the goal is just to summarize the structure of the covariation through a view linear combination of the first set of variables and the second set of variables. And when I say linear combination, because the linear combination will be canonical, the canonical variables. So because if I'm looking for canonical correlation, I actually need to first get canonical variables. And how am I going to get canonical variables? Then I'm actually going to obtain the linear combination. Take a look at what I have here. This is going to give us the set of linear combination from the first set. And this is going to be the set of the linear combination for this second set. And if you take a look at this one, it's like you got a combination of a constant and the input variables in the set 1. And this is another combination of a constant, and input variables in set 2. Okay, now U and V are the canonical variables that I'm talking about. And I'm seeking to get the correlation between U and V. U is a canonical variable associated with the set 1, and while V, this guy right here, is a canonical variable associated with set 2. They can find the mean of the canonical variable. Can you see that now for set 1? And this is the mean for set 2. Then we can talk about the variance, okay, of the canonical variable in set 1. We talk about the variance of the canonical variable in set 2. Can you see that now? And if you take a look at the variance of canonical variable in set 1, this is the formula. Look at that. And of course, this guy here is a correlation matrix. Is a covariance matrix for the first set of variables. And this is like multiply it by the transpose of the constant and the original. Look at that. That's what you're doing. This is for the variance of the canonical variable, okay, for the first set of variable. And this is going to be for this second one. Can you see that now? Then we can, now why am I getting the variance of that? Why am I getting the variance of the first one, of the first canonical variable? Why am I getting the variance of this second one? Why am I getting the covariance of that? The reason being that I'm targeting correlation. Of course, from statistical theory, if I actually want to get the correlation, what am I going to do? To get the correlation, of course, I need a combination of I need a covariance and I need a variance of each, okay? And look at that. That is what you have in the formula right here, okay? This is a covariance, okay? This guy here, okay? Can you see now? It's right here. And this guy here, inside the square root here, is the variance of this first canonical variable, okay? And this guy here is what you have in the square root right here. The only difference between this correlation and the one you have done before is just that here you are dealing with a linear combination. You are seeking, because the U is a linear combination of the first set of variable, and the V is a linear combination of the set of variables in the other group. And now you are now seeking to get the correlation for that. And you know what? You are now, for you to be able to get the correlation, then you need, the goal now is to choose A and B. A and B that I call constant, that will maximize the correlation. I'm going to say that again. We are actually need to develop a strategy, okay, to be able to choose A and B, the constant A and B that will maximize the correlation. Because the idea is to be able to identify, it's like identify the largest correlation in this pair. And believing that maximizing that is actually subject to a condition, and the condition is that this guy must equal to this guy and must equal to 1. And if you can take a look at that, this guy is a variance of the first set. Look at that, the variance. Can you see this guy here? And this guy is a variance of the canonical variable in the second set, and they must be equal to 1. Okay, you remember in a standardized normal distribution, the variance of a standardized normal has to be equal to 1. I think you know that. Okay, and you know what? If it is equal to 1, then we're going to have different at different stages. Like I said, you're actually going to have different so many combinations for the canonical. We're going to have k canonical variable for the first set of variable. We're going to have k canonical variable for the second set of variables. And in each occasion, they must have a unit variance. The unit variance is that they have to be equal to 1. Okay, so in an attempt to maximize the correlation between any them, then the correlation, if they are the same, if for instance, if I'm using the U1 against the V1, the correlation has to be, the variance have to be 1. Okay, and you know what, if I'm trying to, if I take UI against UK, like maybe U1 multiply by UK, of course the correlation must be equal to 0 within a set, within a canonical variable of set 1, within a canonical variable of set 1. Okay, within a canonical variable of set 1. Can you give me 1 second? Just 1 second, okay? Can you give me 1 second? Thank you. Yeah, I'm actually going to call you back. I'm having lecture with my student right now, so I'll call you back. Yeah, I'll call you back. Okay. Yeah, this is Dr. Adepoju talking. And, Auntie Dupe's husband. So I'm having lecture with my student right now. I'm going to call you back. Okay. Thank you. Okay, so can you guys hear me?
Yes.
Thank you so much. Okay, so that is our intention right here. Okay, that's what we're trying to do. Now, let me tell you this. We are, like I said, we're looking for the values of A. If you take a look at what I have right here, the goal is that we actually want to choose A and B that maximize the correlation. That's what we're looking for, okay? And you know what? The idea, we believe that if I actually want to do that, I can actually achieve that by using the eigenvector that correspond to the eigen, the maximum the maximum eigen value, okay, of a certain structure. I'm going to show you the structure right now, in the structure in terms of formula. Now, based on what we just discussed right now, this is a variance of the first set of variables. This is the variance of the second set of variables. Okay, I mean the covariance matrix. This is like a covariance matrix of the first set of variables, the covariance matrix of the second set of variables, and what I have right here is the covariance matrix of, the combination of the two set of variables. Okay, and you know what? This guy, if you take a look at what I have right here, I can actually write that as X and put this, and the general variance covariance will now be this. Okay, where this guy here is this guy, and this guy here is this guy, and this guy here is what I have right here. Okay, if that is going to be the case, we're going to start by doing this. For a fixed vector A, that constant vector is p by 1, and this is q by 1. This is like constant associated with the first set of variables, the constant associated with the second set of variables, okay? And you know what? These are the canonical variables, okay, for this first set and for this second set, okay? You can see that now. And you know what? We are seeking to get the maximum correlation between U and V, between the two canonical variables, okay? If this is a maximum correlation, okay, and you know what? We actually, if we're seeking for that, we actually need to obtain, you know, we obtain this by trying to get a linear combination, okay? And you know what? The first linear combination, okay, is going to be A1 transpose multiplied by the set of variables, okay, in that very first set. And you know what? This guy here can be partitioned. This guy here, the transpose of the constant, is the same thing as is a combination of the largest of the eigenvector. This is an eigenvector that corresponds to the maximum eigenvalue. Okay, now multiplying the eigenvector by this, look at that. This one is just, you know, taking the inverse square root of this guy here. Okay, then you multiply by the set of variable. Okay, this is going to be for the first one, and this is going to be for the second one. Okay, the eigenvector here is E1, the eigenvector in the second one is F1. Okay, can you see that now? Now let me tell you this: the correlation that we are talking about will be the largest eigenvalue of this. It means if you really want to start, you need to first obtain this matrix. Okay, when you obtain this matrix, and how are you going to obtain this matrix? You need what I have here. Look at that. You need this element here. Okay, you need this particular element here. Look at that. This guy here is what I have here. Only again, I'm trying to take the inverse square root. Okay, and this guy here is what I have here. This guy here is what I have here, the inverse of that. And this guy here is what I have here. And this guy here is, can you see that now? You need to first formulate this matrix. Okay. And when you formulate this matrix, you actually need to find the eigenvalue. Now you know how to find the eigenvalue of a matrix. And you know, the number of eigenvalues you are going to get, it depends on the dimension. It depends on the dimension of the matrix, okay? It depends on whether the matrix have a full rank, okay? If the matrix is 4 by 4, then it means you're actually going to get the number of eigenvalues you are going to get will be 4. But you know what? And you know, for each eigenvalue, you're going to have eigenvectors, you know, series of eigenvector. But you know what? The largest eigenvalue is what we want to use. The eigenvector that correspond to the largest eigenvalue. That is exactly what we want to use. And that is the reason why here, the correlation that we're talking about is the largest eigenvalue of this. Okay? So E1 is the eigenvector corresponding to the largest eigenvalue of this, and F1 is the eigenvector corresponding to the largest eigenvalue of this. Now take a look at this is different from this. This matrix setup will be for the first set of variable. We're using, because you know what? The eigenvector that we're actually going to get from here, the E1 is what we're going to use, okay, to be able to determine the canonical covariance for the first set of variable. Look at that. And the one that we're actually going to get from here is the one that we're going to use for V1. Okay, look at that. That's what we're going to use for the second one. So which means what you just need to do is to be able to first have a setup. Okay, you have to set up a matrix for this. You got to set up a matrix for this. Okay, and setting up a matrix for this, you need to get the eigenvalue. Okay, but we need the eigenvector corresponding to the largest eigenvalue in both here and here. Okay, and that's exactly what we're going to be doing here. Okay, now because of that, I'm actually going to walk you into a share right now. All these ones, they are more or less the same, okay? I'm actually going to walk you through a different share right now. Now, you know the mathematical architecture of what I'm talking about, okay? Now, I'm going to go into another share where I'm going to go into the worksheet, okay? Now, I'm going to share my screen right now. Can you guys confirm if you're seeing the canvas right now? Can you guys see the module right now?
Yeah.
Yes.
Okay, now to be able to explain that, to be able to know how to set up a matrix, to for be able to know how to figure that out, I'm going to open canonical correlation worksheet. Okay, I'm going to open canonical correlation worksheet, and that's what I'm going to open. Okay, now I'm going to open canonical correlation worksheet, and I'm actually going to walk you through that. Okay. Can you guys confirm if you are seeing the canonical correlation worksheet right now? Can you? I want us to use data on NFL. Can you see that right now?
Yes.
Thank you. The NFL right here is National Football League in the United States of America. Okay, and you know what? The two examples. The example that we want to use here is just we're seeking for the relationship between the body dimension and physical performance. I'm going to say that again. The body dimension has variables like height, arm length, weight, and hand length, okay? And the physical performance variables, we got 1, 2, 3, 4. The 40-yard time, the 225 IV bench press reps, the vertical jump, and the broad jump, okay? Now, you can see this is set of the first variables, and this is a set of the second variable, okay? Can you see that now? The next thing is that we're actually going to do, you need to set up a matrix. Okay. What I would prefer, like in the last in the last slide that I showed you, I was showing you something that has to do with the covariance structure. Okay. You can use a correlation structure, no problem. Okay. Because researchers can play around. Okay. You can either use the correlation or, matrix, or you use the covariance matrix. Okay. Now take a look at what I have here. The R11 here is a correlation matrix for the first set of variables. What are the first set of variables? I'm referring to body dimension variable, height, arm length, and so on like that. Okay, and R22 here is a correlation. It's a correlation matrix. Here it's like you are having a correlation matrix within a correlation matrix. I'm going to say that again. You are having correlation matrix. It's like having sub correlation matrix within a general matrix. That's what we're having. Okay, the R11 here is a correlation matrix for this. The R22 is a correlation matrix for the second variable that I call physical performance. And R12 and R21 is the correlation, between, when you are looking at the cross, when you are going cross, okay, between the body dimension variable and the physical dimension variable. And you know what? This is the general correlation matrix that we're talking about. Right here, this guy here is the whole of that. Of course, you're actually going to have height, arm length, you're going to have all the variables right here. Can you see that now? And you see you don't have the same set of variables right here. Of course, this is a correlation matrix. Can you see that now? This is a general correlation matrix. But you know what? Within the general correlation matrix, how do I get R11? Oh, R11, I'm actually referring to this. Okay, look at that. Look at this. Look at the first 4x4. Oh, take a look at that. Look at 1, 1, 1, 1. I'm referring to this guy here. Take a look at that. Can you guys see what I'm seeing right now? Look at that. This is R11. Look at that. Okay. And this guy here, if you look at another matrix, if you take a look at this one here, okay, if you take a look at the first 4x4, 1, 1, 1, 1, look at that. This is R11. If you take a look at this guy here, can you see that? Oh, This is R2 too. Can you see the R2 too now? Good job. Look at that. Okay, and look at this guy here. Oh, this guy here is R1 too. And if you take a look at this guy here, this guy here is R21. Is there anyone who have a trouble time getting R11, R12, R21, R22 inside here? Is there anyone who have a trouble time? Can you guys hear me?
Yes.
Okay. I'm going to stop by 12:30 today, okay? I'm going to stop by 12:30 today, okay? Because I need to explain this very well, okay? Now, this is it. This is it. Now, the next thing that we need to do after getting the general correlation matrix of the entire data set, okay, and we already know where to get the R11, R22, and stuff like that right here, okay. Then the next thing is to go on and have a matrices use, set up a matrices use to obtain the canonical covariance. Okay, now I need this guy here. I showed you something like this in the other slide, but that one was in terms of variance, covariance. But like I said, you can also use the correlation, okay? Because I'm using the correlation right here, okay? Now, I need to obtain this guy here. This is going to be for the first one, and this is going to be for the second one. All you just need to do is to know the right formula, okay? Take a look at that. This is different from this. Look at the first one here, R11, right? But look at that, R22. R12, R21, R22, R11, R21, R12, R11, R22. Can you see that? Now, if you try, since you already, what we advise that you should do from here, okay, write R11 out. Write your R11 out. Look at your R11. Can you see your R11? The first 4x4 is going to be your R11, okay? The first 4x4 is going to be your R11. The second 4x4 is going to be your R12, okay? Right here, the second 4x4 in this row is going to be your R21, and the last 4x4 will be your R22, okay? You just need to get all that, you multiply all that. Now, what I'm trying to tell you right now, when I multiply all this is what I have. You can actually use your software, but I need you to put it out like this. Even when you are using your software, when you're using software or whatever, you still need to put it out like this. Look at that. So this is what I got for this guy here. And you know what? This is what I got for this guy here. Okay. So the next thing that I'm actually going to do now is for this guy here, for this matrix of 4x4, I need to get the agent value. Okay. And after getting the agent value, I need to get the agent vector. But you know what? I need the agent vector that corresponds to the largest agent value, okay, of this one and of this one, okay? And you know what? If I really want to do that, I can write a code in R. Since I already have my matrix defined, my matrix, this guy here, cc.mat1, I'm using that to represent this guy here. And cc.mat2 is representing this guy here, okay? And if I want to get the agent value for that, I'm going to write agent for that. Look at that. What I'm trying to talk about right now, this guy here are the agent values, okay? But you know what? These are the corresponding agent vector. But you know what? I need the agent vector that corresponds to the largest agent value. What is the largest one here? The largest one is 0.88194133, okay? And what I'm seeking now, what is the agent vector corresponding to that? That's what I'm going to be seeking. I'm going to do the same thing for the second matrix, okay? I'm going to get, so these are what I'm putting right here are just the agent values. The agent vectors for this second matrix. And these are the agent vectors for the first matrix, okay? And you know what? I need the one that corresponds to the, if you take a look at what I have here, I'm actually going to work on this one because this one, the one that corresponds to the largest agent value. Okay. Now, the next thing that I'm actually going to do after doing that, I need to first obtain this correlation right here. And the correlation is actually going to be the square root of the agent value. Look at that. Can you see that now? What I have right here, I'm taking the square root of each of that. Look at that. Can you see that? That is exactly what I have. And you know what? This is for row 1. Okay, row 2, row 3, row 4. Okay, using this guy here. Can you see that now? Now, the next thing that I'm actually going to do is to be able to compute my constant. Okay, I need to compute my constant. Okay, and if I want to compute that, I'm actually going to be using the agent value. The largest agent vector that I talk about, the largest agent vector to multiply R11 the square root, and you of course you know your R11. Okay, so here I'm going to, when k equal to 1, I'm going to have from k star from 1 to 4. Don't forget, why do I have from k star from 1 to 4? Because I'm actually going to have 4 agent vectors. Because why do I have 4 agent vector? Because the matrix here is 4 by 4. Look at that. The matrix is 4 by 4. And I'm actually going to have 4 agent values. And each agent value will have 4 agent vectors. Okay. So this is it. So I'm just trying to show you. So this one is a constant for the first set of multivariate sets. Okay. Don't forget EK here. You are actually using the agent vector, the largest agent vector, okay, the one that corresponds to the agent value. Okay, you can use this one to get the A1, A2, A3, A4. Look at that. That's why you have A1, A2, A3, A4, and you're going to use this guy here to obtain for B1, B2, B3, B4, and the A1 up to A4, B1 up to B4 are the combination of A and B that I talked about the other time, that we're trying to seek, that can maximize the correlation. Okay, so look at that. You know, this one just I round out to 3 decimal. You know, that's just what you're trying to see right here. Okay, can you see the worksheet now? And the next thing that you're going to do after getting the constants, then the essence of getting the constant is just to use, because the constant is what you're going to actually use to form the linear correlation. I mean, the linear that will form the linear combination that we talk about. Okay, so with this constant now, I can set up a canonical variate, that is canonical variables that I will eventually use in the canonical correlation. So, but I need, you know, the optimal values of this constant. Okay, and that's exactly what I generated right here, and that is exactly what I'm actually going to be using now to formulate the canonical variate that we eventually use. Okay, to figure out the canonical correlation, then I'm going to be using the combination of the constant a's. Okay, and this is going to be a standardized variable. I'm actually going to standardize the variable in the first set of variable. I need to standardize all these ones, and I also need to standardize all this one. Of course, you know the reason why we need to standardize, right? I told you in factor analysis, because if you don't standardize, some variables will dominate the others, and because they are not in the same unit, and that's why we need to standardize. When you want to form your canonical covariates after developing the constant A and B, you actually need to standardize, and that is why you are seeing Z, you know, Z1. Okay, then I guess the first set of variable have been standardized. We're going to multiply by the constant A1, A2, and so on like that. We're going to do that to the second set of variable, and when we do that, that will enable us to be able to develop a lot of canonical variates, and in such a way that the variance of the set of canonical variates here and here has to be 1, and their covariance have to be equal to 0. okay? And at the end of the day, what we're going to be seeking is to be able to get the the covariance between, you know, that set of variable. Look at that. If you look at that one, and u, and what is u here? This is canonical covariance, okay? And that is what is spelled out here. Okay, I'm going to find this one out. Then I just need to find, this, okay? And what is my a? A here is actually going to be the constant, okay? The A1, the A2, and so on like that, okay? And the B's too, okay? Look, can you see that now? And what we're doing right here is actually to find the inverse, because look at that. This is like getting the inverse of A and getting the inverse of B, okay? The inverse of A is the same thing as a correlation. I mean, it's the same thing as a covariance between that and that, okay? Look at that. And for B. So that's why we're trying to find the inverse of that of A and the inverse of B, okay? And you know what? You can also do, if I want to find the proportion of the sample variances of the standardized, first set of variable and second set of variable, that can actually be explained by arrow canonical variate, okay? And you know what? If I want to do that, I'm actually need to do this. It's just using the inverse, multiply the transpose of inverse. That's what we're doing right here. Look at that. The transpose of inverse of A multiplied by that. I'm actually going to have this. I'm actually going to do that for B as well. Okay, take a look at that. And when you are done with that, then you can actually also go for this. Okay. Now, you can read up this material, and you can also use that to carry out a test to be able to see whether that is actually zero, whether the covariation between them is zero. Is the covariation between them equal to zero between the two set of variable. When you look at it in a in a cross tabulation way, if the relationship is zero, it means there's no connection. I talk about the other time, if you take a look at what I have here, this is actually testing where, this actually testing body dimension and physical performance. So it's just trying to say there is no connection between them. When this equal to zero, when this equal to zero, and this is a test statistic that we're actually going to use. And of course, the P, the Q, the N, but this guy here, the P, the rho I squared is, this is actually going to go from, I start from 1 to P. So which means you are, of course, you are using the rho that we computed before. Look at that. You're using this one. Okay, so now what I'm trying to tell you right now is that this is the test statistic, and this is how to do that in R. And of course, this is a p-value associated with the test. But there's something I'm actually going to, this is a worksheet, but there's something I actually want to, let me, I'm going to open, I know my TA, we actually walk you through something like this on Friday, but you know what? I want us to have a test. I mean, I want to have a demo right now on this same variable. And before I get it, I have a demo. I'm actually going to show you something again. I'm going to share something with you again that I attach. And that is that thing, you're actually going to use it on Friday. My TA, we actually going to walk you through that on Friday. I'm going to show you right now. It's attached to your, now, can you guys see the dashboard? Can you see the module right now? Can you,
Yes.
okay, thank you. Now, if you take a look at this, there's a material here that is called Canonical Correlation R codes. Now, that is a code for that worksheet. This is the code for the worksheet. Now, I'm going to show you what we have in the code right now. Okay, I'm going to stop the share, and I'm going to show you what we have, what I put in the code. Now, I need you guys to confirm if you are seeing it right now. Can you see the code right now?
Yes.
Okay. Now, this is the NFL. This is the data, okay? when I copy, look at all of that. This is when I told you we're going to standardize, right? This is the standardization. Now, you're going to see something right now. I'm going to copy this into R. You're going to see something right now, like I said. Let me share my R. Can you guys confirm if you are seeing my R interface right now? Can you see my R interface right now?
Yes.
Okay. Now, if I copy that data, if I copy that here, I'm going to copy that here now. Okay. I copy that here now. Okay, this is my data set. Can you see that this is the one what we just talked about right now? The eye, the arm length, and so on like that. Okay, this is what we just talked about in that worksheet. Okay, now, and if you want to see the data, I'm actually going to write the NFL. Okay, the NFL. If I click enter, can you see the data now? Oh my God, this is a lot. Look at that. Okay, this is the data set that we're actually talking about. Okay, can you see that now? Okay, so when you take a look, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it starts from here. 1, 2, 3, 4. And this is going to be in the first set. 1, 2, 3, 4 in the second, in the other set. Okay. Now you don't need to load any package. Just copy this into R. Now take a look at that. I'm going to go. I'm going to copy. How do I standardize? Okay, I'm going to copy that into R right now, standardizing the variable. Look at that. I've copied that into R. In fact, what I need you to do right now, if I cancel everything, I'm going to go into that material. I'm going to copy everything and I put into R. You're going to see. I'm going to copy everything into R right now. Everything. Copied everything. Oh, it's going. It's loading. Can you guys see my R? It's going, 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 going. Can you see that now? Running. It's running everything. Running, 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 running. Can you see that now? Good job. It's done. Okay, so I'm going to show you one by one. I'm going to show you one by one. Okay, I'm going to show you. You're going to see something right now. Okay. Okay, I'm going to start from here. Okay, let me start from X1. You know, how do you load the two set of variables? Okay, take a look at this. Can you guys see that now? The body dimension is X1, and X2 is a physical performance. So this is X1 and X2. I already have it. Okay, and of course, I'm trying to say my P, the number of variables in the first set, the number of variables in the second set. And you know what? What I have right here, I've been able to develop the correlation. Okay, can you see that now? Okay, now when you take a look at what I have right here, the correlation that I was showing you before is this. Look at that. If you want to get that correlation, since you already have your X1 and X2, you're just going to write R equal core C bind X1 S2. You're going to have this. Okay, if you want to do that in R, look at that. So this is a combined correlation that I talk about. Now, if you write this code, you know you need R11, you need R12, you need R21, you need the R22, which is the sub. How do I extract my sub correlation right here? Okay, this is the code for that. Okay, can you see that now? This is the code. And let me tell you something. It means if I write R11, look at that. This is the code, the matrix for that. If I add R22, can you see that? If I write R12, oh my God, if I have R21, can you see that now? These are the sub, these are the word. You need this a lot. Okay, because the formula is actually going to be based on this. Look at that. Okay, so to set up that, I already show you it's part of the code that we have already written here. Can you see that now? And after that, the next thing that you're actually going to do, okay, you need to obtain the eigenvalues and the eigenvectors of R1, stuff like that. And how do you do that? Okay, that is exactly what we're trying to do right here. Okay, can you see that now? These are the code. So all what I just wanted to do is to follow the code. You know, I generated a matrix for you before, right? Okay, so take a look at that. Okay, you take a look at that. You know, here I said the CC matrix 1, and I'm trying to get the agent value of that matrix. And the agent value, you know, this guy here is a combination. You know, if you take a look at that, the formula that I gave you before, they are all coded out here. For cc.mat1, this is the formula. Okay, this is how to code that in R. For cc.mat2, this is the formula. Okay, I told you before. Can you see that now? So these are the one inside here. Okay, and if for this one, if you want to have access to this guy, let me see. If you want to have access to that, of course you can copy that and run that. Okay, so in the end, you're going to see your result. Look at that. I was doing something the other time. I got an A, the inverse of A and stuff like that. This is it. And if you want to get the covariate, the what you consider now, that is how to get that. Okay, my TA will actually walk you through this on Friday. Okay, you're going to walk you through this one by one. Okay, only that before that Friday, you know, I put this code for you to run, and you'll be able to see. Look at that, a lot. You got a lot here. Okay, you can run a test that I talked about the other time. Okay, look at it. The p-value of the test is there. No, how to do that now is actually here. Can you see that now? Is there anyone who want to ask question? This is going to be the last. This, you know, this is how far I can go today. Is there anyone want to ask question? Is there anyone? So I will advise that you guys should go through. I've given you enough materials that you can actually work on canonical correlation. And on Friday, my TA, my teaching assistants, will actually walk you through all this in R. Okay. So do you have any question for me today before I go? Is there any question? Are you guys hearing me?
Yes.
Okay. The I think the you know, so is there anyone who have not seen the grade for the midterm too? Is there anyone who have not seen the grade for the midterm too? If there's anyone who have not seen the grade for the midterm too, should actually contact me. Okay. Now I want to thank everyone for attending my lecture today. I hope you guys enjoyed the lecture today. I will advise that you walk through the worksheet that I attached and the hard codes. Practice those hard codes before Friday. Okay. My TA is actually going to walk you through on this. So until tomorrow again, that I'm actually going to come your way. Stay safe and do have a good day.
Thank you.
You
Thank you.
welcome. You welcome.
Thank you.
You welcome.